Sums of arithmetic and geometric sequences. And then here's just some vocab. A geometric sequence is a sequence where each term can be obtained from the previous one by multiplying by the same non-zero constant. And then an arithmetic one is a sequence in which each term differs from the previous one by the same fixed number. And then these are just the formulas to find the common difference for like an arithmetic and a geometric one. This one is the first term plus n minus 1 times the common difference. And then this one is the first term times r to the n minus 1. The first one is a sum of a, is it finite geometric series. And the thing is the common ratio cannot equal 1. The formula is the first term times 1 to the 1 minus r to the nth over 1 minus r. And then here is an example for that one. So this one, it gives you a1, the first term, and it gives you the common difference. And it wants you to find the sum of the first 8 terms. So you just input everything in. This is first term, and then 1 minus the r term to the 8th power, because you're finding the sum of the first 8 terms over 1 minus r. And you just simplify and get 1 times 1 minus 256 over 1 minus 2. Then you further simplify and you get the sum of the first 8 terms for this geometric series is 255. And then sum for the infinite geometric series, the absolute value of the common ratio has to be less than 1. And this is like the more complex way to write it, but it's really just the first term over 1 minus the common ratio. Okay, and this one you're finding the sum of the terms given. So first you have to find the common ratio, which you just do by putting a2 over a1, and you end up getting 2/3. And then you get 27 over 1 minus the common ratio. And then further simplify to get 81, so the sum of that geometric sequence is going to be 81. And then the sum of the finite arithmetic series is n times the mean of the first and last terms is like the easiest way to remember it. And then this one you're finding the sum of the first 30 terms. So you get n is equal to 30, and then you have a1, which is 5. Okay, and then you have 5 plus 29 times, you have to find the 30th term first, so you get 5 plus 29 times 4 equals 121. Then you just put it into the formula, so you get 30 times 5 plus 121 over 2. And then you figure out that the sum of these, the first 30 terms in this sequence is 1,890. And pretty much all these, you just have to like know the formula, and it's easy because there's not many components to it. And for the sum of an infinite arithmetic series, it's always going to be infinity. And then this is the place.